I'm Will Crittenden. I'm the technical evangelist for RackTop. And Dave Hughes is going to be joining me here to do some demonstration and explanation. In particular, we're going to look at our user behavior analytics and our ability to do active defense. Now, why is that different? Why is it unique? Right? When we talk about active defense, the ability to stop in real time and not be post-process, but to be preemptive, that is going to be completely unique in the ability to stop data exfiltration. Right? We mentioned how ransomware has elevated itself over the past decade or so. Now we're seeing extortionware becoming as much of a problem as ransomware. With the data exfiltration piece, the problem we see is that users who have rights to data are being compromised unwittingly at times, and that data is leaving the data center. Once the data is left, there's no ability to recover it back. So we're going to show you how we block accounts, how we can remediate and track the incident, and how we can alert other systems as well, creating a true cyber resiliency across the data that is most important to your environment, to your business.
So what we're talking about, of course, everybody on the call here and people watching this video, they understand what this is. We're looking at file shares on the network, and we manage those through permissions through Active Directory. We can access these with read-write permissions, just as Jonathan said earlier. Now, just to frame this demo environment for you guys, I'm an administrator. I'm logged in currently with the credentials that can pretty much do anything, as well as give myself permissions. I am not being checked because I'm actually a trusted entity. However, the way that we implement the zero trust framework within the BrickStor itself, we're watching every transaction real time and determining, should this person be here? Should he be doing this? Such as, I might want to go in as the administrator account, and I want to look at the employee reviews because I want to give myself some better points. If I want to go in and access this, give myself permissions through the HR directory, I should not be in here, but I'm going to go ahead and open this file up and start editing. Now, once that occurs, the BrickStor is actually in the background watching these types of scenarios and looking at what every user and every transaction is happening. So if I were to go look at over here at the BrickStor system itself, we have an unacknowledged and unusual activity incident going. I actually received a Slack message, a Teams message, as well as an email that, hey, from a communication standpoint, something weird is going on and somebody needs to review that. So if I go into here and look at this fix area, we can see that, hey, the Edward Snowden.admin account is actually accessing information and data. We can see exactly the system he's coming from. And we classified this as, hey, this is unusual. He doesn't typically come here. He's given himself permissions and now something's abnormal here. We can actually even see what is this user account accessing. We see that it's opening up that employee review template. So it's already going through the actual changing information on that file. So with that type of incident, I might want to call as an admin. Now, notice we didn't block this one. We can elevate the settings to block this action, but I need to trust but verify. Let me call Ed up and find out what he's doing. Why is he in this folder? What's happening? When I called him, he told me he was on vacation. He hasn't been on the network in 2 weeks. So we now know we have somebody that's accessed his privileges in his account inside our network, and they're snooping around to see what they have access to. So now our security team can jump into action, as well as on this watchers area, I can include other areas of my group, or I already have them automatically included in those alerting messages from the beginning. From a storage perspective, I've protected everything. I've protected my data, and I've made sure from a security perspective, everybody's in the know.
Just a quick question on this. Is this something that you've explicitly said, hey, this folder is sensitive and so anything should be alerted on? Or is this something where this user doesn't usually access this folder and so you're alerting on it because of that? Or what triggers that alert specifically? Maybe I missed that.
What you're looking at, I'm showing you here today, is basically an out-of-the-box implementation. We're always looking for somebody with elevated privileges poking around, accessing information they haven't before, and those type. We're monitoring the behavior analysis of an end user or an elevated privileged account that's accessing information on the BrickStor itself. So this is an out-of-the-box function. Somebody maybe mistakenly with that admin account deleted a bunch of data. We would have automatically caught that and stopped that Again, out of the box implementation. Now, and how we're doing that, so this is the really nice part, is we actually monitor all the behavior analysis of what end users are doing on the BrickStor itself. So I can look at this from a top level down, all activity from all users, as well as what that activity is. So in real time, I can see there's other users in my environment, but here's the activity that sponsored that event a little earlier. So in real time, we're watching what these end users are doing, whether it's a read, write, modify, copy, delete. And then with that, we can actually employ enforcers around that, what we call assessors, to say, hey, this doesn't look right. This looks like malicious. Let's stop this action. So because of the information we have and we collect in real time, we're able to jump into action with our real-time active defense. Now, with the behavior analytics, I like to look at this as also a forensics tool. So I can look at things that happened in the past. I might want to know everything that Cindy has ever touched within this environment. So I can pull those types of operations out of here. I would just type in Cindy's name and everything that Cindy has ever touched within the environment. I can pull a historical report. So I can give you that from a NIST framework perspective. I can give you all the auditing and logging and hand it off to an auditor or to a security professional. Say, hey, look, this is everything that has been accessed and touched by this particular user account. So I like to also look at user behavior as an additional tool within my arsenal, as a forensics tool, is what is happening with my data.
So because this is behavioral analytics, and I know the answer is going to be it depends, but I'm going to ask it anyway. How long does it take for the behaviors for your system to see that this is an abnormal behavior? Because of course, on day one, there's no behaviors. So how does that work?
So we actually can stop, and I'll show this to you. We can stop unusual activity and ransomware in under a second without the use of any agents. And it doesn't need to learn behavior because our AI actually has a definition and rule set to go against. Because of our knowledge and know-how and our patents within our security system, that's what we put into the BrickStor operating system from an active defense standpoint. So with that, I'd like to show you a couple scenarios that actually will demonstrate those capabilities. So this particular user, this is Dave. He's sitting on the network. He's actually accessing that network resource. You see 10.2.19.1 on the network. And he's watching a nice little peanut butter. One of my favorite things is peanut butter and ice cream. So I do a couple of demos with these. Now, Dave decides he might want to, hey, I'm going to take a lot of my information on the network and I might want to take us all home. Something we definitely don't want users to do. We prohibit the people putting things in the cloud or into a Dropbox account or copying it down to a local USB stick. I don't want that to happen. We prohibit that action we don't tolerate that within this environment. So as you see, Dave's copying that information down, and within a few seconds there, we identified that, hey, this looks bad. We need to stop this action. Something that the Dave account's doing doesn't look right. If I hop back over here to the BrickStor, you see now we have a real security alarm going on. So if I hop over and look at the alert that popped up, we have somebody he's excessively accessing information and data. He's copying that data over to USB stick, and we need to stop that. That's against policy. We also now know that's the Dave account, what system he's doing it at, and especially what files he potentially got away with. So we have actual evidence. So that's one of the big things about the BrickStor is everything is recorded. So we actually have the evidence. We have the proof. So because we can show that we don't have false positives because this action actually happened. So from that concept, I might need to alert the security team, say, hey, we need to keep Dave in his seat. Please go out there. And he's probably got a USB stick with a bunch of our data on. He's planning to leave the building. And we prohibit anything being copied off of our network anyway. So we are able to stop because of that user behavior and active defense capabilities. We're able to prevent a malicious or something accidental happening within our environment. Again, we trust Dave. He had read-write permissions. He's got a lot of access to everything. And just read-write, you can actually do a lot of damage.
I'm just wondering, this excessive reads, are you somehow able to figure out that he's copying to a USB stick, or is this a general policy for copying to any local device, including the local hard disk?
Yeah, this is actually monitoring. He's moving data off of our system, whether that's USB, cloud, wherever that might be going. we prohibit anybody taking data off of the network. So
Okay,
we
so-
stopped it from that perspective.
So that would apply to the local hard drive on the laptop or whatever. It's not specifically finding USB by data speeds or anything like that.
Correct. Yes.
Okay, cool. Thank you.
It's funny because this is I love seeing these demos. I actually showed my kids this. They're like, Dad, what are you watching? I explained it to them. I was like, let's put it this way. Like, it's like a sting operation for ransomware. It's a sting operation. It's like, stop what you're doing. And it's so cool to get to see it, especially because of how granular, right? Because you've seen a lot of just historically, I have like security software, EDR solutions and the way they act, but to see such a level of depth, it's really amazing and how to respond to it.
Thank you. So for another kind of a demonstration, we're talking about, again, active defense and its capability to thwart these types of external things. So, well, we kind of saw an attack from an internal, somebody we trusted, right? They didn't have to hack the environment. They had full access, unfettered, unencrypted the data. They have the security keys. They can copy anything they want. So how do we prevent that? We put the BrickStor in place and we can actually monitor those types of actions. Now, from an external threat, we have Cindy here that's going to do a little demonstration. She accidentally clicks on one of those links. And I know everybody on this call gets those emails. Hey, Southwest Airlines, or you got a free gift card here and there. And she accidentally clicked on it. Now, embedded in that, there was a ransomware virus. And I like to use the Ryuko virus because it's pretty nasty. It not only encrypts your data, but it also tries to exfiltrate. So it tries to take it out of the building and to try to shut you down at the same time. And we're now seeing ransomware people really just skipping the shutting you down part and just want to steal your data and hold you for extortion. So the big thing that we can do is I'm going to go ahead and launch this ransomware on her desktop. And what you'll see here within a matter of a second or two is that process just stopped. Her video is cached right now, but it just stopped playing. And she's also lost access to all the network resources. I don't know if you can hear it in the background, but I'm getting a lot of alerts on one of my PCs saying we have something going on. So if I hop back over to the BrickStor, we see have another alert that's coming in. It says, hey, we have a Ryuk. We've actually identified that because we update our signatures out of band. But we're really looking at the behavior analysis. If we didn't recognize the virus itself, because we focus on the behavior, this would actually say unknown. So we're really looking for those unknown unknowns or those true zero-day attacks that nobody's seen before, so we can prevent that data loss in the first place. Again, we now know it's Cindy's desktop. She's the one that's affected. We need to see where she's coming from that particular network segment or IP address. And we see the actions we took against Cindy's PC. We've blocked her host. So maybe something in a silicon, maybe something on the physical system she's not currently logged in is actually using her account. So we need to block that system from any more access to the data. That's what the bad guys want. We've actually blocked her user account so that account can hop around the network and use other devices or other network segments to try to access that data and continue the attack. We've also placed a hold on our snapshots. Now, one of the nice things about our snapshots, the way we do things, is we have the capability of placing these things on hold. If you notice, we have a rolling snap. So every minute we're taking a snap, so we're always aware of what the data rate of change Jonathan talked about earlier. We see all those little changes. You'll see also a little indicator here on these snapshots that this snapshot cannot be removed, deleted, overwritten until somebody's responded to this incident. Now, we have snapshots from months and months and months ago, but these snapshots in particular are of interest because they're involved in an incident. You also see that we're indexing in the background so that we're creating a metadata index, almost like a catalog, like a backup server. So we can actually do search and finds of specific files across the entire system to do multiple types of file recovery within that box as well. So I'll hop back over to the incident itself and show you how we would actually remediate. So again, we had hit by Ryuk ransomware. Cindy was the attacker, and she came from that specific system. We now have an alert that came in at 3:47. I will show you right here. We can see it down to the file what happened. So we see the Dave test 1 file was there before the attack, and now it became a Ryuk encrypted file. We also see basically 2 files were hit during this attack. Within milliseconds, we were able to identify and stop this. So I'll go ahead and as an administrator to the storage, I'm going to acknowledge that I'm working on this case. Now that also shoots off another email or Teams message to my security team, letting them know that the storage team or the infrastructure team is taking care of recovering data. They're already in action mode, and the security team can now go visit Cindy and do what she needs to do with her from a laptop perspective. But you also see right here all these operations in 8 milliseconds. We were able to respond. So there was 805 operations in 8 milliseconds when this virus attack started. Now, from a response perspective, I've already acknowledged that you see my name is now associated. Everything that we do as an administrator to this system is also monitored and audited. So I can actually view all the files, and I want to remediate and restore. I mean, that's the big thing. I need to get Cindy back into business. The only person that was affected during this attack is Cindy. The rest of the organization is still online and making use of their time at work. We do not have to send them home because we've actually isolated and stopped the threat immediately. So what I want to do is I want to select all the bad files. I want to be able to remediate this. I need to clean this up. And I also want to restore and put all the files back that were there just a minute ago. So you see, we have a kind of a one-click button to run this recovery plan. So I'm going to go ahead and remediate and restore this in one click. If you want to get down into it, you need to actually do forensics for further. We have a manual capability as well. So we can quarantine a file so that other Microsoft or Symantec might need to do a forensics analysis on this data. So we can isolate those files and put them in a directory that's untouched or inaccessible until we give it access to that team. So again, I'm just going to hit this recovery plan. Go pop on through, and I basically removed the Ryuk ransomware encrypted viruses files, and I've recovered the original file back down to the block. And we're also doing a hash check on the original as well as the recovered so that we can verify that it is 100% identical to the file prior to the attack. That's
really slick. One thing that I noticed as you're going through this or was thinking about, obviously you said the word metadata. I think your literature talks about metadata intelligence and how you use that. Obviously anything with user behavior analytics is going to require some level of metadata logging on what's actually going on day to day. I'm assuming that all of that is stored somewhere safe and secure. I'm just wondering how that works, because obviously that could be another treasure trove for attackers. So I'm wondering, how long is that stuff kept? Where is it kept? And how do you manage the metadata itself?
Metadata is managed by the system. As you can see, it's right here from a storage perspective of visibility on how much we're actually consuming. Because there's a lot of metadata. We've actually wrote our own, our own system. So everything we control and everything's deduped, compressed, and encrypted on this device. So all the data and the metadata is contained on the same, basically what we call a pool or an aggregate of storage. It's also protected from a parity perspective or those types of things. And it's also replicated. We're looking at from a disaster recovery standpoint is even though I had a disaster, I still have to be compliant. So we make sure we keep all these metadata and records with the actual data so that we have compliancy standards that we are always keeping in check and in balance.
And also, it could also be forwarded to a SIM or SOAR as well. So you could forward all that audit and behavior information to other systems or a central log repository for an extra level of protection and to be used by other systems.
And just to reiterate, what Dave's showing you is a piece of malware that is known to work about 80,000 files a minute. We were able to stop it with only 2 files being affected. So to continue this, of course, as the administrator, once Cindy, I get the all clear from the security team, I would restore her access. Now, if this is something that happened as an accident or somebody did do something creatively, we can actually create hall passes for periods of time that would expire. This one was a real deal. So I'm going to go ahead and say, hey, the attack has been recovered. We recovered from the incident. We're clean again. And we're going to go ahead and give Cindy access back now that the security team has called the all clear. So I'll lift those blocks against her and close this incident out. And once that happens, Cindy, of course, would log into her new laptop and she would be able to open up those files again on the network resource. Thanks for that, Dave. What we have shown you there again is the ability to stop in real time any sort of data attack, going from ransomware to insider threat, any sort of exfiltration. And the important thing to understand is anytime you have data that needs to be secured, if that data would be impactful to a business, were it to be stolen or encrypted, that's when you need to have real-time protection, right? Recovery from that event is not nearly as helpful as it is to remediate and prevent upfront. So some of the common use cases, what we see across our customers, as Jonathan mentioned, enterprise, IoT at the edge. We do have HPC use cases as well. If you think about HPC environments in particular, there's a lot of work being done to come up with some value or some amount of data. And at the end of that, when the data is generated, we probably don't want that data to, again, be exfiltrated. Secure backup and archive repository is another interesting one for us because we have the ability to do a virtual air gap that is unlike any of the traditional air gaps that you've seen in the marketplace, simply because we can replicate and not replicate the encryption keys and make that a completely air gapped and geographically disparate copy of data that we are certain will never be impacted with malware. User file shares, home directories are the easy ones we've talked about. That's probably our most popular use case. And again, that online archive, because we're able to ensure chain of custody across the data that's being stored. We've seen this recently with several police departments locally. I'm here in Virginia and a couple of departments here around my hometown. The surveillance video or the body cam video or evidentiary data that has been stored and is being used as case workloads has been impacted by ransomware, and we've actually had cases dismissed because that data wasn't protected correctly. Of course, healthcare is another huge use case for us. Anytime a patient's life is in jeopardy, being able to secure and ensure that we don't have any impact to that data being online is of top concern, as well as manufacturing to ensure, again, that chain of custody. So with that, we've kind of shown you how we operate in the NIST framework, how we have access control and compliance, and how active defense can stop in real time.
So what about IPv6 support? If I'm accessing this either from a user side or from an administrative side, can I do that from an IPv6 only network, or is this a v4 only solution today?
Support both IPv4 and IPv6.
I've got a quick question about resource requirements. So if we're using this in a VM to front end on an iSCSI storage solution or something like that, what kind of processing and memory requirements are necessary to provide effective performance on this platform?
The default, the least amount of requirements we support is 64 gigs of memory for a virtual appliance and minimally 4 virtual processors. Yeah, we want you to overachieve. So that's the minimal support. So most implementations go out, they start around 64 gigs, maybe 6 to 8 virtual processors, depending on the amount of currently connected users and current connected drives or those mappings. So we do that, of course, on connected devices or users, as well as bandwidth.
So can BrickStor observe and protect itself from any type of behaviors that are anomalous for its own system administrators?
We audit system administrators' changes. Yeah. We're not doing proactive defense where we're locking them out or anything like that. Yeah. But that is can be audited and alerted.
Audit alerting is all I'm at. Yeah.
Yeah. And then we do have the ability to also detect when somebody's probing the system too, like doing things that seem abnormal to get access or gain access to the system.
Yeah, you wouldn't want to lock yourself out of your own protection system. And then my next one was, so in the demos, you're using people's accounts, but we know that not all bad behaviors that or anomalous behaviors that can happen happen by people, but by service accounts or other things? Is that just something we didn't have time to see, or how does that work?
I think the easier demonstratable is with a user account. Of course, creating a system or a service account and then creating an attack is a little more complex.
Mm-hmm.
But yes, we can actually do that from an application standpoint or from a service account. We monitor all activity from any device or any user or any account that's trying to access our data in real time.
Building upon that and kind of back to Chris's question about, well, how did you know? Or like, right. So we're looking at admin credentials or service accounts. We alert and let you get visibility, because that's part of the hygiene. There's a lot of times where people are using service or admin accounts when they shouldn't be, and they should be using our user account. So we want to bring that visibility and attention and hygiene to that. But on top of that, you can then say, okay, this is allowed, like a backup job or a data move that's going to move data using a privileged account or a service account. We can provide rules that say, yes, you're allowed to use that account during these timeframes and on this data set and from this client. And so you can be very restrictive of where you allow that and how you allow that. And you can even have it expire. You can make it not a permanent rule, but expire at a period of time or a certain number of days.
One more quick question here, and maybe this is obvious to some folks, but I think it might be worth drilling in, is, when we're talking about user behavior and entity, or user and entity behavior analytics, and maybe even like kind of privileged account management and these kind of things. I mean, those tools obviously exist outside of just a storage specific context. And I'm wondering if I'm at an enterprise where I've already got a PAM and a UEBA and I've got all that stuff locked in and tied up, is there an advantage to BrickTop above and beyond that? And what might that be?
Yeah, the advantage is where we sit in the infrastructure, which is that we're going to see everything. You can't really circumvent some of the other tools. So sometimes those are relying on endpoints and other agents, as well as we're going to have a lot more clarity as to what's being accessed and more fidelity about, did you access the whole file? And we can do it on box and in real time and then alert those systems. And so even when we talk to those other vendors that do run PAM and other classification and monitoring and kind of a digital rights management and things like that, they see us as complementary because we're covering gaps that they're not seeing. And so we're kind of another sensor to illuminate some dark spots within the infrastructure.
So the one that I would say is a big one is, from a storage person, I designed storage from performance for the application. I didn't foresee all the 10 other bells and whistles you were going to add on top of it, because we put an account for maybe VMware, maybe some other application. We have a little bit of space there, but I didn't account for the 10 different monitoring user behavior, all the other activity, all the security on top of that. So now my performance of the storage that was originally architected is now very low. So because we're a 128-bit file system and now modern architecture, memory-based architecture, we built this storage system with the mindset of the security first. The enterprise features, everybody has to have that. That's table stakes. But the big thing we have to make sure it stands out and does not impact that performance is our security features are built into the system. They're not a bolt-on.
And the other point on that is anything that's sitting outside of the storage is generally looking post-process. And if I'm talking post-process, even if it's within 10 minutes, that's 800,000 files that could have been encrypted, as opposed to me stopping it at 2 files.
The newer variants are even more destructive. They're only encrypting the first 4K of a file, so they can actually pretty much rip through a file system. And because we have these capabilities to stop it pretty much within a couple milliseconds, we really prevent those outages and really provide that cyber resiliency that a lot of infrastructures and enterprises do not have today. I'm glad we can actually provide these to those guys.
And think about that too, right? Anomalous detection was the reason that variant has come about. If I'm talking about any of the solutions that are looking for those anomalies, there's a threshold that has to be overachieved before the anomaly alert comes out. If I'm only touching 4K per file and I've got 100 terabytes, think about how many files I can touch before I get an anomalous threshold detection.